class, and I sent out a message earlier about this update. So I decided to set the green group. You guys, I think, are fine, but the green group was really behind because they didn't meet on Friday and they didn't get, anything from chapter 7 except for online material. I think they'd probably be okay moving forward, but I feel better about rolling back chapter 7 out of that exam. I'm sorry, that might disappoint some of you. My rolling there for chapter 7. And I'm sorry for that. It actually does benefit you because if you remember exam 4 is split into 2 pieces. They're mini exams. So it actually means that exam 3 is now technically a mini exam. I'm still going to count it as 100 points, but you have less material on it. Most, I think it's easier material. So exam 4A, that mini exam will cover chapter 7 and 8. And chapter 8 is kind of a longer chapter. We've been in the spring of really short chapters, 5, 6, and 7. And so I hope we get all 3 of those on one exam, and then chapter 8 all by itself on an exam. Anyway, the whole point is that you'll have 2 chapters on the first mini exam, which means, I have sort of basic questions I want to ask, and then I have more in-depth questions. It means that you'll probably get fewer in-depth questions. But you benefit is the whole point of this, even though, you guys I know have been studying really hard for chapter 7, and you've already had it in class, and you're all ready for detail, and you can just say, I think, 95% on it? Maybe. Okay? But that's the way it is. I decided. I'm going to put my fist down and say that's what it is. Okay? We'll have a help session tomorrow at 3 o'clock over in 165 right across the courtyard. And that other announcement I sent out. Is there something else? What? In class versus what? Oh yeah, so the test is on Responders Monitor, but if you want to come into class, I sent out a form for you to respond to. If you want to take it in here, I'll bring paper copies of that exam just like last time. You can do so. You still have to put your answers on Responders, but you can just sort of set your computer off to the side and take on paper. Okay? Questions for now? I thought that we might move. I don't know what I thought we'd do today, but what we're going to do is review for the exam on Wednesday. So, are there particular questions? It's just in chapters 5 and 6, or we can go through the old tests and sort of plan it together. Unless y'all have particular questions. Yeah. All right. Let's go into the workbook. So y'all have those exams in the back of the workbook, and we'll sort of peruse those, working through some. I know we've done a number of them, but let's go into the back for. Let's see what we've done. Exam 3. Let's look at number 2. So one of your first questions on the exam is going to be a conservation of energy problem. In fact, you'll have 3 or 4 conservation of energy problems similar to number 2. On each of these, you need to ask what type of energy does the object have at different points. And so one of the tricky parts on this one, just make sure you don't miss this, is that sometimes it has a speed at the beginning and sometimes it doesn't. So here, at point A, because it has a speed, it has both kinetic energy and potential energy. Now, if this speed was 0, it would only have what type of energy? Potential, right? In fact, on the very first question, I posed this, and I asked you, what type of energy does it have here? So I want you to think about that. And really, it's, if the speed is 0, no kinetic energy. If the height is 0, no potential energy. I think students often miss those, not because they don't understand it, but because they're just not paying attention. So make sure you pay attention to that. Here, I want to know what is the height that the cart comes to a stop up here. So I know V is equal to 0. So I know kinetic energy is equal to 0. And the potential energy is mgh. So my conservation of energy is going to look like this. Kinetic energy plus potential energy at point A will equal to my potential energy at point E.
1/2 mv squared. I'm going to go ahead and put in the values here. 1/2 m times 4 squared plus m times g times 10 meters. That's the height right here, is equal to mgh. And that's going to be my height right here. Notice those m's, they cancel out. They'll always cancel out unless you're dealing with a spring. And when you're dealing with a spring, we'll do one of those in just a second. The spring potential energy doesn't have m in it. It's not dependent upon mass, so it doesn't cancel out. Now I have 1/2 of 16 is 8 plus 100 equals g, which is 10 times h. So 108 divided by 10 is 10.8 or 11 meters. So you'll definitely have several like that where you have to figure out what is the energy. Sometimes or the velocity or the height based on the energy. One of the things you're going to see on this test is that there are a number of questions that don't have figures with them. I recommend that when you read through that question that you try to make your own figure. I think this problem is made easier because it has that figure and it allows you to sort of think about what's going on. But if you can construct your own figure for a problem that doesn't have a picture, it'll really help you with that problem. Okay? So when you come to a problem that has no picture, which you'll find 3 or 4 or 5 on the test, make sure you try to draw a picture. And don't just sort of jump into the math, but draw a picture and draw the arrows, all the distances. That's true for the collisions and for the energy problems. Let's do number 5 here too. So this is a similar problem. You're going to have one like this, where I have a spring-loaded gun, and you compress it by this amount. It has a mass of 0.020 kilograms. That's the steel ball in that gun. And then I give you the spring constant, and I want to know the initial speed of the steel ball. So what this is saying is that I have this ball compressed right here. It's compressed by this amount, and then after it leaves, I want to know what is the velocity of that ball. So I know over here I have what type of energy. On the left, initially, what type of energy do I have? Only potential. So I have potential energy of the spring. After that, the potential energy of the spring is completely spent because that spring is stretched out to the equilibrium position. And so all I have left is kinetic energy. You should follow that same process. Draw a picture, then write down your equation, and then solve the equation. So this is going to be 1/2 kx squared equals 1/2 mv squared. 1/2 of k is 250. That's my k value. X is 0.03 meters squared, and then that's equal to 1/2. Here the m doesn't cancel, so that's 0.02 divided by or times v squared. And then you solve that for v. Courtney?
Could you cross out the 2 halves since there's 1 on each side?
I was just about to do that. All right? They say you shouldn't point your finger at people. Is that right? All right. So, yeah. Now I can solve that for v. Has anybody done that yet? What is it? 3.4. So if I solve that, I get 3.4. Dividing through both sides by 0.02 and taking the square root. Alrighty? Why don't we look? We can come back to some of these, but let's go ahead to chapter 6 problems. That's probably what you're most concerned about right now, right? Because your quiz is on chapter 6. So let's look at some chapter 6 problems. Oh, we'll come back to this. Yeah, let's look at chapter 6. Looks like we've done some of these. So why don't we go down to the next exam? That's the exam 3 from fall 17. Okay, so like number 15 is one where I don't draw you a picture. It's still a collision, but I don't draw a picture for it. So it's useful to just draw a picture. I know it helps me a lot. I have a person with a mass of 60 kilograms. Sorry, let me mute this. A person with a mass 60 kilograms, they're standing still and they throw an object with a mass of 12 kilograms. So this person is holding a ball of 12 kilograms, and they both have a velocity of 0. That's the initial state. And then in the final state, the person throws the ball in that direction, and then presumably this person is going to go in that direction. I mean, they will, right? Because I know that here my momentum is 0, and here my momentum also has to be 0. And if the person throws this ball in that direction, in order to have equal but opposite momenta, then this guy has to be going in that direction. Okay? So I can go ahead and get rid of 2 answers. I know it can't be A or B, because I already know that my speed has to be opposite that of the balls. Now I'm ready to solve it. So I say the initial momentum equals final momentum. 0 is my initial momentum, is equal to 60 times V final plus 12 times positive 2. That's the velocity of the, oh wait, no, I'm sorry. I made a mistake. Right? The velocity of the person is plus 2, not the ball. Oh goodness. The answer is probably there, by the way, doing it that way. So let's fix this. This should be positive 2. And then this will be V final. So actually now I can get rid of, well, no, it's still going to be negative. It'll still be a negative answer. So that's 120 divided by 12, or negative 10 meters per second. Solve this, I get negative 120 divided by 12 is equal to VF. And so that's negative 10 meters per second. Yeah, Courtney?
Would you be able to explain, for say, problem number 14, let's say, continue.
Yeah, of course.
It has for the inelastic collision, you make the velocity negative if it's going to that opposite direction. But for an elastic collision, such as like the old exam problems, are they going to be positive just because they're still going in the same direction, or is it going to be negative for velocity?
Okay, so yeah, on these, especially these times, well, on any of them, that you want to make sure that you get the signs for the velocity correct. So here, the 3 meters per second is positive, but the 4 meters per second is negative. It's just simply because it's to the left. That's what you're asking, right? Like, why are the signs negative? How do you assign the signs?
Yeah, I did one for fall 2016 on number 13 specifically, and I did it the way, but I made it opposite, so I got it wrong. I just didn't know why that one was all opposite, but this one had like the negative.
The fall 16 was all fun?
Yes, fall 16 number 13. I understand how you did it, I just didn't know why that one was negative and the other one was positive.
Okay, yeah, this one is negative, and this one is negative because they're both to the left.
Would you be able to go over them?
Yeah, I'd love to. That's in fall 16, you said.
Yes, sir.
This one right here? Okay. I think I might have had a mistake in this. I'd have to go back and look at the actual exam that I gave the students. What was the answer supposed to be? Do you know?
It's supposed to be 20.
20? Yeah, I really needed to give them some sign information or some direction. And I'm not sure what the direction was. I might have, when I gave it to them, I might have fixed that question. Do you know what the direction was in that question?
It just said they collided, so like, it's
I
like
didn't
they
know
were. Yes, I looked at the video. You had them somewhere.
where they went.
Yeah, okay. So really the way that I should have done this is that, I might have fixed it when I told it to them in class, is that this should have been a negative value. Or I should have said, oh, the velocity was to the left or right. That's probably how I would describe it. I'm sorry, that's just my mistake. I might have fixed it in the class. Hopefully I did. If I didn't, I heard about it, I'm sure. So, okay, Courtney, does that make it clear for you?
Thank you.
Yeah, Freeman?
Does this problem simply that like they're colliding motions going in the same direction? Like one's catching up to the other?
No, I think I'd have to go back and look at it, but I think that the 3 kilogram is going in this direction with 12 meters per second, and the 5 kilogram is going in this direction at 25 meters per second. Yeah, but it's not really clear in the text. Okay. If you
Yeah, it's just like they're both left positive, you get 20, but that made sense to me when I was trying to work it, like drawing that out.
is 20 the right answer?
20 is the correct. Yeah, that's what was marked correct. If you left 12 and 25, both positive.
Okay, well then that must have been what I intended then. That I have a 3 kilogram right here.
Let me think about it. The per kilogram is going slower, so it could have just been the 5 kilograms going faster. Rams into it.
Yeah,
Like that. Yeah.
I like the way you say that. I think this is probably how I intended it. If that's what the right answer was, but it still needs more clarity, I think. So Freeman, yeah, they're going in the same direction then, and so it would look like this. And then afterwards, the final velocity of this object, the 5 kilogram, would be 20 meters per second. And then I'm asking, what is this final velocity of this object, which would be 20 meters per second. Any way to work that, you say 5 times 25 plus 3 times 12 equals 5 times 20.
It's 20 times 20. Just because it says the first object is 3 kilograms. No, but that part was right. 5 times 25 is the final velocity.
So this is actually 20 over here. Okay? I'll try to have it more clear. I know that y'all are in a different spot than in the class. Usually when I give these tests like this, they're very confused if I can answer this question. But if you have a situation like that where you come up to an issue and you think that there is, a lack of information, just, stop, send me an email later, but speak in it to your camera and I'll go back to your question. All right? Okay. Any other particular questions right here? Let's look at some, like number 14 here. This would be an impulse or a Newton's second law problem, where I have a 0.2 kilogram steel ball. It drops down, it bounces off of this plate and goes the opposite direction. Its speed here is minus 3.6.
I need your consent on a few items to continue.
Oh, for goodness sake, sorry. 3.6 down and then 6.4 up. And I want to know, what is the force? The force is delta P over delta T. And so to find my momentum is going to be m times delta V divided by delta T. So that's going to be 0.2, that's my mass. And then the change in velocity, I'll write it up here, is equal to 6.4 minus negative 3.6, or that's going to be 10 meters per second. So 10 meters per second divided by my change in time, which is 0.03. So it's 2 divided by 0.03, 67 newtons, right? Okay? You'll definitely have a couple like that, 1 or 2. Yeah, Courtney?
What are the types of concept questions that'll be on the exam? Because I feel like that's what I've struggled with the most going through the whole thing.
Yeah, let's go to Moodle. It's Moodle. So if you go here, all the concept tests are here. This is a good place to practice those conceptual questions. I know we don't do these in class. These are in the back of your workbook too, by the way. But Let's just download the momentum ones. So, like for example, here I have an open cart that rolls along a frictionless track. As it rolls, what happens to the speed of the cart? In this case, what's happening is the cart is collecting mass, and as it collects mass, that means that the speed has to go down, because momentum has to stay constant, right? As m goes up, v is going to go down if it remains constant. So this one's going to slow down. You'll see questions like that, like what impacts the change in momentum? System of particles is known to have a total kinetic energy of 0. What can you say about the total momentum of the system? You've seen questions like this on the old test. In fact, a lot of perceptual questions come from these questions. So if the kinetic energy is 0, that means that the speed of the object is 0. Because remember, kinetic energy is a scalar quantity. And when you add up the kinetic energies, they can't cancel one another out. Like if you have a system of particles that are moving, it's possible for them to have 0 momentum. If I have one particle moving in this direction and another particle moving in that direction with equal and opposite momentum, then they can have 0 momentum. But here, if they have a total kinetic energy of 0, that means that the total momentum of the system is going to be 0. Because they have a speed of 0, because kinetic energy is a scalar quantity. I'll have some questions exploring that, by the way. What's a scalar and what's a vector quantity? Energy is scalar. Momentum is a vector quantity. Don't forget your other scalar and vector quantities too. Like some vectors include force, acceleration, velocity, displacement. Scalar quantities include time, speed, distance, energy, work. This is sort of the same. I'll leave this. Here, I have a small car and a large truck collide head-on, and they stick together. Which one has the larger momentum change? Which one experiences the larger force? I have a small car and a large truck hit one another. Which you would think, right, that it would experience the larger force? But don't forget Newton's third law. The Newton's third law says for every force, there's an equal but opposite force. And so if the car hits the truck is going to hit the force with a bigger, smaller, or same force. The same force, right. So it doesn't matter what your mass is, you're still going to exert the same force when you come together. The big will exert the same force on the small as the small exerts on the big. They would both have the same momentum change because the force is delta P over delta T. They're going to have the same momentum change. The way that I would practice these is I would print them out, 6 slides to a page, and then fold them over so that you have the answers on one side and the questions on the other side. And then just quiz yourself. This one is more about momentum and what momentum is related to. That momentum, F, oops, oh, sorry, I don't have a pen here. Well, I don't have my pen. I'm sorry. But here, F is delta P over delta T. And so I have the same force and the same time for both of these. And so therefore, they're going to have the same change in momentum. One of these objects, the heavy object, will have a smaller velocity, but it's still going to have the same change in momentum. This one is a useful one, talking about a small beanbag and a bouncy rubber ball. If you drop them on the floor, one bounces and one just falls dead onto the floor. And so which one has the larger change in momentum, or which one has the larger force that it impacts onto the floor? Remember when we were doing those problems where they bounce off, and the change in velocity, if they bounce off, is actually the sum of the initial and final velocities, not the difference, because I have that whole thing with the sign. And when you do that, it increases your change in velocity, so it causes a larger change in momentum. So here, which one of these is going to feel the larger impulse, or which one will impart the larger force to the object? The bouncy ball, right, because it has a bigger change in momentum, so it's going to impart a bigger change but we always did the popping towels, women and guys go on. And so guys do that. I know women, you might not do that. I don't know if they'll do that. Where you walk around and pop one another in the rear with a towel. Don't do that, dude. The guys do it all the time. In fact, we made a part of it where we just make a rat tail. You know what a rat tail is? You know what a rat tail is, right? Yeah, where you take a wet towel or an ant towel, you fold it up in a particular way, and you pop it out and then bring it back. It hurts a lot. But the bringing back is really important because you get that change in momentum. You have to bring it out and then sling it back so you get that change in momentum.
Why do y'all do that to
I don't know, Sam.
Why is that fun to you?
I don't know. I mean, it was fun. It doesn't sound fun right now.
Yeah, hindsight's 2020.
Although I find that if I have a towel, I just want to pop people with it. Which my wife does not like, unfortunately.
I wonder why.
Yeah, right. Anyway, it's because of that. The rubber ball imparts a greater momentum or impulse. This is really like a calculation problem. I do have some questions on the exam about objects splitting up like this. That if I have an object that splits up or explodes or separates in some way, like this one does, this uranium nucleus, it's initially at rest, and then it splits into two fragments. These fragments are going to have all the same momentum as the original object. And since the original object has zero momentum, these two fragments will also have zero momentum. And because they're going in opposite directions, then they have to have equal momentum. So here, the one with the greater momentum is that they'll both have the same momentum, equal but opposite momentum. Which one's going to go faster, by the way? The smaller one, right. So the smaller one will go faster. This is a similar problem we did in class, where you have an object that separates, or like you shoot a gun, you want to calculate the recoil speed. I want to look at another one. Well, I didn't see it. Okay, Courtney, that's a good place to go. I know that was sort of a long-winded answer, but that's a good place to go to see and practice the conceptual questions. And then, of course, looking at the old test. All right. Good questions? Yeah, Megan?
Can you give us problems where you change the velocity by so much, it changes the kinetic energy by so much, how would the momentum change?
Oh, yeah. If you look back at some of the old tests, I'll just make one up. So let's say you change the velocity. And the kinetic energy increases by 16 times. By how much does the momentum of that object increase? I know that kinetic energy is equal to 1/2 mv squared, and momentum is equal to m times v. And so if my kinetic energy has increased by a factor of 16, that means that my speed of this object has increased by what amount? It's increased by a factor of 4, right? Because if I multiply this value times 4, 4 squared is equal to 16. Then if the speed of the object has increased by 4, that means the magnitude of that velocity has also increased by 4. So my momentum has increased by 4. So if the kinetic energy increases by 16 times, that means that the momentum increases by 4 times. Or if the kinetic energy decreased by, say, 1/4, what would the momentum be? If the kinetic energy decreased by 1/4, what would the momentum, how would the momentum change? Huh? If the kinetic energy is now decreased by 1/4, what does that say about the momentum? Decreased by half, right? Because if this decreased by 1/4, that means that the speed decreased by half. A half squared is 1/4, which means the momentum will also decrease by half. Courtney?
If you're changing the kinetic energy, whatever that number of changes, could you just say the square root of that?
Yeah, if you're looking at the velocity or the speed in this case. Now, if it was the mass changing, which sometimes it is the mass, if you increase the mass by 2, that means the kinetic energy increases by 2. But yeah, usually it's the speed, although sometimes I've asked about what happens with the mass. Okay? Good question. Yeah, Alex? Oh, yeah. So we didn't really get into this in the class at all, but it was in the notes. Elastic collisions. You have a question, I'm pretty sure, about elastic versus inelastic. Elastic collisions, this last question, I'm going to have to get to the quiz. These conserve energy and momentum. And inelastic collisions only conserve momentum. A lot of collisions lose energy. Most collisions in the universe lose energy. If you bump into somebody in the hallway, which you should, it's far apart. But if you bump into somebody, that loses energy. It deforms things, it makes sound, it heats up stuff. So most collisions in the universe are inelastic. Almost everything. And all of those collisions conserve momentum. Some collisions in the universe, like atoms, when they come close to one another, they collide without touching, right? Because they have field forces in play. Those are elastic collisions. We approximate some collisions as elastic, like billiard balls. They don't lose much energy. Good question, Alex. If you have more of a question about that, ask at the help session. We can talk about it more. I'm going to go ahead and give you your quiz. Yeah, Freeman? I'm going to put it on the board. Okay? You ready? I'll put the clicker base up soon. Logan, can you see that? Logan, can you see that? Yeah. If you can't see it, just let me know. I can zoom in.